the project related to the commercial case, okay, commercial plane related case, okay, and from that project part, one component has been done, that is the wing component, and today we'll be going to design the other component, okay, the major other component what we have, the fuselage. So we'll be going with that. So according to our requirement, we have to design, we have to create, and we have to design our fuselage, okay. So overall length of this fuselage I mentioned 124.75 feet, okay. Sorry, this has to be here 124, 124. So this value not belong to this one. Let me delete this. Yeah, this is right, and this value has to come here. It's a mistake, okay. 124.75, okay, not 124.9 in, it's 124.75. that is the overall fuselage length. Okay, 124.75, that is our overall length, okay. And apart from this, I have given any other parameter. Yeah, the front view, it should look like this, okay. And side view, we have fuselage side view, it should look like this, okay. Which means after creating and designing this fuselage as per the given dimension, then the view, front view and the side view, it should look like this only, okay, with proper dimension, whatever I mentioned that, okay. So by using this dimension, like the dia also have given 3.75 meter, okay. And in next slide, even I have mentioned the sections. Yeah, so this is our second component, because first component already we have done, the main wing is done in our last class. Today we will be going to design this fuselage. The overall length is 124.7 feet, and other dimensions, other parameters I have already shown. So by using that parameters, okay, the fuselage parameters, we have to create and we have to design our fuselage in the Open VSP software. So front view of the fuselage, here we have that part, okay. This is that front view and the side view after designing in the Open VSP, or after inputting your values, the side view should look like this, and the top view, okay. So now what I'll do, I'll go to sketch, okay. And here we know that we have the parameters, the fuselage parameters, okay, I have given. And apart from that, even I will give other parameters. The overall fuselage structure is like this, right? Okay, it's a rough sketch. So here I'll just split these sections, because to design in this Open VSP, we have to get the shape like this only, like what we have here, okay. See, from nose to tail or tip of this fuselage, okay, from here to here, the dia is not same, right? Okay, from here to here you can say it's same, okay, and the dimension also I have given here, okay. So for by using this 2D sketch, okay, and the views, the rough sketch view what I have given here, the dimensions, okay, by using that we have to get the same side view, okay, and the front view it should look like this, mid side like this, and at the end the exhaust part, okay, APU side, the end of this fuselage it should look like this, which means the overall dia is not same from nose to end part of this fuselage, okay. Here it's varying and here also it's different, so that's why what I'll do, I'll give other data also, okay, which means I'll split this into 6 section, 1 2 3 4 5 and 6, okay, then I'll get that required shape. So that's why what I'll do, I'll just split now. So this fuselage what we have, okay, so now what I'll do, I'll call this as my nose section, this section, this one, okay. So that's why what I'll do, I'll make the section into 2, 1 2, okay, 3 4 5 and 6, okay, and from here to here I'll mention the length, overall length we know that overall length of the fuselage, that is 120, how much I mentioned, 124.75, okay, 75 feet, okay, that is the overall length which I already given from here to here, that is our overall length, okay. We know that as soon as we add the fuselage in the Open VSP, we will get default fuselage, okay. For the default fuselage we will give the overall length, right? So simultaneously even we will do in the Open VSP. So I'll just open the Open VSP. I will select the geometrical part, that is the fuselage. I will add. Now here we have the fuselage, and this fuselage is the default fuselage, okay. So for this default fuselage, we have to use our geometrical parameters or the values what I have mentioned here or what I have given, okay. So by using those values, we have to do changes to this default fuselage as per our requirement, okay. So overall length I have mentioned how much, that is 124.75 feet, that is the overall length, okay. So simultaneously I'll just input that value, I'll come to design. Here the overall length is 30 feet, okay. It's a dimensionless quantity, okay. The number it's just 30 unit. So at the end you can convert that 30 into as per your requirement, okay. You want in terms of feet or meter, as I told in the previous classes and all, okay. For our case we have the number, that is 124.75 feet. So I'll just call the unit as feet only. So that's why the length I will use 124.75 and enter. So overall length change, right? So this is our fuselage overall length. Overall length data is given, okay, which means this data I have imported this at 125.75 overall length. Okay, but when I see the structure, top view is not as per our requirement, right? Like I mentioned here, it's not like that. Even front view, it's like completely circle. Now, as I given the data here, we have to split this into 6 section now. Okay, 0 to 6. So what I'll do, I'll come to Open VSP in the section part. In this section part, okay, I'll just check the default what we have. The 0th section, 1, 2, 3, 4, only 4 are there. Okay, for this default fuselage, only 4 sections are there. But according to our requirement, what I'm telling, just split this overall length of this fuselage into 6 section. Okay, and that is also I have mentioned here 1, 2, 3, 4, 5, and 6. It's already mentioned here. So what I'll do, I'll just split now. So this one is our 0th section, and in between 0th and first section I'll split. I'll just insert. Okay, this is our first section, second, third. Between third between third and fourth, I'll split into one more section between this and this. Okay, why? Because just to get this kind of shape. Okay, I mean like this shape. As I told, if you want to vary the dia of the fuselage from nose to end of that fuselage, then because of the variations in the dia, of course we have to split. Then only we can easily work out on each and every section, from nose to this section, and from this section to this side, and from this to this, and from this to this. Then like that, after splitting, no, it will be become very easy to design your model. Okay, like what we have done for wing. Okay, from here to here, its shape is different. Okay, that's why we have called this as a first section, and the rest we have called the second section. Similarly, we have to split because the dia of the fuselage is not same throughout overall this length. Okay, throughout the length of the fuselage, the dia is not same, and the cross sections also I will just mention here now. Okay, so splitting is done, right? 4, 5. Let me verify once. 1, 2, 3, 4, 5, and between 5 to 4 to 5, I'll split here, insert. Okay, now yeah, now we have overall 6 cross sections: sixth one, fifth one, fourth one, third one, second one, first one. Okay, okay, this is done. Now we know that overall length is 124.75. Okay, but here I have not given the length of each cross section from one end to other end, right? So that I will mention now. So for first cross section, okay, from 0 to 1, or again 1 to 2, 2 to 3, okay, 3 to 4, 4 to 5, 5 to 6. Okay, which means we know that our fuselage length is like this. Okay, from this 0th section to this 6th section, we have other sections like 0. This one I'll call 0, 1, 2, like this I have mentioned here, no? 3, 4, 5, and sixth one here. Okay. So now from here to here, and from here to here, again from here to here, from here to here, okay, from here to here, and from here to here, the length. Okay, we know that overall length. Okay, the overall length is 124.75, right? 124.75 feet. Okay, that is our overall length of this fuselage. Okay, now 0, which means this one only. Now what I'll do, I'll just come to sections. Okay, currently 0th cross section. Okay, 0th cross section in the sense no need to do anything, just let it be. Okay, come to first cross section. Okay, first cross section here, the default number of views is 6. Number of views in the sense this frames, I'll just increase the frames. Okay, to a little bit, so you can able to observe I'm increasing the frames. Okay, wireframe. Here from now I will give the dimension. Okay, from here to here, length, take it as 3.98 feet. 98 feet. Okay, which means it's already I have calculated, that's why I am giving that value, because it's not that much easy to get the value. Okay, especially to get this kind of shape. Okay, so it's already analyzed, okay, verified, and that's why that value which I have got, that is what I am sharing with you. Okay, which means this section, okay, is placed from 0th section with some distance. That distance I mentioned here, 3.985 feet. Okay, and next from first to second, okay, this length, that is 29.33 feet. Okay, simultaneously we will do in Open VSP. Okay, now what I will do, I'll come to first cross section. Length I have given, okay, how much? 3.98 feet. Okay, 3.98, enter. And the cross section type, that is also very important for this 0th cross section, let it be point itself. But whereas this first cross section, it's not a pointed type of cross section, right? If I give you the same pointed type of cross section, then the fuselage will be like completely pointed, which means this part will be completely pointed. I don't want point. Okay, so instead of that we have some dia, no? So just use the cross section type. Now instead of point, we'll use cross section type. Okay, so we'll use the ellipse type of cross section. Okay, and yeah, if you are using ellipse type of cross section, okay, for this first cross section, type of cross section, if I'm maintaining ellipse type of cross section, then with respect to that we'll get parameters, right? Height and width. So height and width will add now 6.5, enter. Okay, and 5.5, that much I'll maintain. Okay, because the value which I mentioned, which I have shown here, the same value I'm typing here. Okay, all of you just note down this value. Okay, for the cross section, first cross section value 6.5 feet and 5.5 feet ellipse height and width. That parameter I'm giving, just note down the parameter, and the length also I mentioned 3.98. These parameters are very important. This one, and this one. Note down these three. After that, what we'll do, we'll jump to second cross section. Okay, in the second cross section, let's increase this wireframe also. Okay, why I'm increasing? Because just to smooth this geometry, that's it. Okay. Okay, this is done. And in the second cross section, the type of cross section is ellipse only with some default value. Okay, so and here I mentioned the length of that cross section. Okay, second cross section, if you are placing from 0 to here, length I have given. Okay, not this one, sorry, don't get confused, sorry, not this, from here to here length. Okay, that length is 29.33 feet. Okay, so we'll use that 29.33 feet. Enter. This is done. Now the cross section type is ellipse type of cross section, and the diameter, I mean like height, note down this value 13 feet height, and width 12.5 or 2, let it be, I'll just type 3, 12.3. Okay, this is done. Now next, second cross section is done. No, now jump to third cross section. Okay, third cross section. Now we are on third cross section. Here what we have to do, you have to type the value. Okay, third cross section, it's here, so I'll not mention length, so I'll just give that value. Sorry, this is our second cross section is done. No, first one and second one, this one, second one, and third one we have here. Okay, let me change the color so that yeah, this is our third cross section. So that value I'll just mention. That 2 to 3, the value, call it as how much. Here we have the overall length 124. No, so take that as 80 point or 80 feet. 80 feet. Okay, this one from here to here, 80 feet. Okay, so now we are on third cross section, and the length of cross section, which means where that cross section has been placed from this nose side, that is 80 feet away, right? So 80, enter. 80 point, just type any value, 09 or 02 or 80, that's it, enter. Okay, now next, okay, and ellipse type of cross section, that is what we are preferring. And for this case, same height 13.0, enter, and width 12 point, same will maintain. Okay, what we have used for second cross section, same will maintain for third cross section. Okay, 12.0. 123, enter. Why we are going with the same? Because we know that, okay, as per our this case, okay, here we have the third cross section, right? Okay, so this third cross section, and it's almost the same now, so that's why use the same cross section type. And now we'll jump to fourth cross section. Fourth cross section value, the length, use that as this one, use this as 91.18. Okay, so in this rough diagram, the length is like, you can feel it is a decreasing, but don't worry, just concentrate on this diagram. Okay, because what I have drawn, it's a rough, it's not according to the scale, right? So that's why the overall length is 91.18, which means the fourth. Okay, third. Okay, now we'll come to Open VSP. We are on fourth cross section. The overall length, okay, which means the cross section where that has been placed, 91.18 feet away from north side. Okay, and the cross section type, it's ellipse only. Let's decrease that to 12.07. Note down these values because these all values that I am typing, these all values are analyzed correctly to get that shape. Okay, this is done. Okay, now come to fifth cross section. Fifth cross section that has been placed 123.50 feet away from the north side. Okay, use this value 123.502 feet away from north side. Okay, and here we have to decrease now because we know that uh, see, the dia is decreasing. Okay, which means the shape of that fuselage is decreasing from this end to this end, so that's why now we have to decrease this parameter. Okay, the cross section type, what we are placing the ellipse type of cross section. Okay, the height and width we have to decrease now. Okay, so that's why just decrease that to 4.5 and 1.1 feet. Let's take 1.5, enter. Just note down these values because these all values are calculated and it's analyzed correctly to get this shape. That's why. Okay, fifth cross section is done. Now come to sixth. So here we know that we have to close now this geometry. So that's why use pointed itself. Okay, and the overall length is 124.75, which means from this end to this end the overall length is 124.75. Default value we got. Okay, no need to type anything because here we have mentioned the overall length is 124.75, and after mentioning that overall length 124.75 for each and every cross section, okay, we have placed, okay, whatever each and every cross section we have placed, and okay, for that cross section the length is also have mentioned. Okay, use that length. Okay, this is our fifth cross section. This one is our fifth cross section, fourth cross section, and third cross section. Okay, here just okay, I will call this an first, second, just delete this, call this as third, fourth, okay, fifth, and the last pointed one, because here for this one we are not calling 0 comma 0, we are calling sixth one, no? So here 0 to 6, okay. In between that, 4 cross section we have 1 2 3 4, okay. Let's take in that way to avoid the confusion. And the same figure it will look like this, okay. 1 2 3 4 5, first one and the last one, the cross section type is 0 comma 0. Between this first and last we have 1 2 3 4 and 5 cross sections, okay. And for this last cross section 0 comma 0, what we have, that one we are calling sixth cross section, and for this initial one we are calling zeroth cross section in our Open VSP. So that's why here we have totally from 0 to 6, okay, the cross section from 0 to 6, and each and every cross section has been placed away from the nose side, okay. So this value is done, no? Okay. Now we'll check. Let me increase this number of views just to smooth this geometry. For this pointed case is not required, let it be. Okay, for this case we'll just increase. Okay, see, you can observe that I'm increasing the wireframes just to smooth this geometry, that's it. Okay, for this case also I'll just increase. And third cross section here also will just increase. Second cross section, let's increase this also, yeah. So now you can able to see the wireframe I have increased because just to smooth the geometry, right? Yeah, so let's check now. So we have done with this, right? Okay, now let's change the view, front view. Top view, left side. Okay, okay, let's shade, then we'll get to know clearly. Yeah, okay. Front view, left view, okay. So it's not that much smooth, right? So now we will smooth this, okay. The side view it should look like this, okay. So what we'll do little changes. Now I'll come to each and every section, okay. So I'll just increase the z value, not much, minute value, okay. 0 point some value, 151413, any value, enter. Because see, as per our requirement, fuselage is not completely horizontal, this part is not horizontal to the ground, no? Okay, and this end also is not horizontal, okay. I mean like not parallel to the ground, so that's why I have to change along z, okay, for each and every cross section. Second cross section, here also I'll just increase for cross section, same as maintain 0.8 enter. You can even type 2 3, no problem. Fourth cross section, here I just use 2 points in value, or I'll just use 2, that's it. Fifth cross section, just round up this to 6 or 5 point some value, 5.9 or 8, or round up that to 6. I just use 5.8, enter. See, as soon as I type, here you can able to see the changes. Okay, initially it was just 5 or some lower value, enter. Okay, now I'll just increase this, which means I'm a little bit tilting, okay, that part little bit. I'm taking upside from the ground. Okay, and the sixth one, this also 5.8. okay, this is done. Now to smooth this geometry, let's come to skinning. Okay, in the skinning you can smooth the geometry by varying the angle. So I'll just use 90-degree round of angle, and this strength. Okay, while discussing this skinning, I told why we have to use the skinning. Okay, to just make smoothing over the top and right side and all. Okay, so that's why I'm just giving required values. Okay, right top side I want to smooth, so that's why I'm just giving the strength and the angle. Okay, let it be this minus 90. Okay, and this one also. And let it be this to lower value. Here for this case also I'll increase the strength 1 point. Let's increase this to 1.8 or 9. Okay, okay, now let's check. Yeah, okay, so we have done with our geometry. I'll just use the wireframe. Okay, yeah. So see, this is not that much pointed, so that zeroth cross section you can little bit maintain a circular type. Okay, like this, right? Let it be pointed or circle with some small amount of dia. So we have done with our fuselage part. I'll just maintain this pointed it's only. Okay, I'll shade this one, and let's keep this in an ISO view. So this is our fuselage. It's done as per the given geometry. Okay, left side view. Right, we have achieved our model, which means we have done with our fuselage as per the given dimensions and all. So this is all about today's topic. All of you just practice. Okay, doing in the Open VSP is not that much hard. Okay, the only important part is that conceptual design, the sketch, what will be covering, okay, for your required model. Okay, that 2D sketch is very important. Once you're done with your 2D rough sketch and the dimensions what you are using or what you'll be using for your model, the overall length, how much you want to keep, okay, and other parameter what we have, okay, sections which you will be placing, where you will be placing, okay, each and every section if you want to split, then where you will be splitting, okay, or where you will be placing from the nose side, where you will be placing each and every section. Okay, that analysis has to be done correctly. Once your that 2D analysis part is done clearly, that is conceptual sketch is done clearly, then it's very easy to generate that model or to create that model in the Open VSP. Just we have to give the input data and we have to enter. As per the input data, we'll achieve our required model. That's it. Okay. So this is all about today's topic. I'll stop here. We'll continue in the next class with our next component. Okay. Thank you.
Okay, thank you, sir.
Okay. Thank you.